Okay, so we're moving on to an inclined plane now. So a body of mass 3√3 kilograms on the surface of a smooth plane inclined at 60 degrees is acted on by a horizontal force of 15 newtons. Calculate the normal reaction of the plane on the body and the acceleration of the body up the surface of the smooth inclined plane. So let's get our diagram going. So we've got a 60-degree plane. There's my body. Okay, so let's put some forces onto that. It's got a mass of 3√3, which means it's going to have a weight of 3g√3 to give it its weight. The normal reaction always acts at right angles or perpendicular to the plane it's in contact with. So the normal reaction, okay, which I'll call N, I call it R on the previous example, but often an R is for resistance, so I'll put an N there for normal reaction. And then it's also acted by a horizontal force. So horizontal means it's coming in along the lines on the page. Okay, so if it's going to accelerate up the body, that's going to be a pushing force. It's not going to be a pulling force, or it's going to accelerate down. So if we imagine that that force is going to be pushing there, that's going to be the same as acting over there through the body, and that is a 15g force. And that's going to cause it to accelerate up the plane. So the acceleration is going to go there. And we are going to take the acceleration up the plane. So we will have our plus x plus y. And it's always useful when you're not instructed where to take as positive, if you add a little diagram or a little annotation on your force diagram to show what direction you're taking to be positive. Right, so that's 60 there, so I know that on my incline that there is also 60, and I also know from the fact that we've got parallel lines there that that is 60, which I'll use when I come to resolve that 15g. Okay, so when I resolve in the positive x direction, that's going to be Newton's second law, because that's the direction it's accelerating in. So that's going to equal ma. There's no acceleration perpendicular to the plane, so the sum of the y components must equal 0. Okay, so let's start with the x components. If I start here, that is going to be positive x, because it's pulling up. So in the x direction, I'm going to have 15g. Now that's 60 there. If I make that right angle, here's my my parallel component fx, which is adjacent to the 60, so that will be 15g cos 60. The normal reaction is perpendicular to that, so that has got no component up the plane. Then I'm into this one, which is going to be negative 3g√3, and this is the one that is going to be the flip, where it isn't going to be cos of 60, it will be sine of 60, because that's the one that we're practicing in the second example. So I got 15g cos 60 minus 3√3g sine 60 equals ma. Well, the mass is 3√3 a. So I want to find the normal reaction and the acceleration of the body. From that, I'm going to be able to get the acceleration. But before I do the maths, let's finish with my resolving. So Fy, it's going to be n, all of that's acting up the plane, and then I'm going to have minus 15g sine opposite, and minus 3g root 3 cos, and that's going to equal 0. Okay, so from 1, to get the a on its own, I have to divide the whole thing by 3 root 3. So a will equal 15g cos 60 minus 3g root 3 sine 60, all divided by 3 root 3. So to make life a little bit easier with that g, I can store 9.8. Now I was looking, and this doesn't go up to a g, which is a shame, but if I say that I'm going to store that in a, then when I type this in now, rather than have to put times 9.8, I can put 15a cos 60. Let's set the fraction up. So on the top, 15a cos 60, close bracket, minus 3a root 3 sine 60, and then on the bottom 3 root 3 equals, and you get 5.7 because this has got g in it, so it needs to be two significant figures. Now if I had to substitute a in, this is another complication, that's my final answer, so I would round it. If I was substituting a into the second part of the equation, I would keep it as the full string and then round the final answer to two significant figures. But in this case I don't need to. So for 2, to get the n on its own, I have to take those across, and I get 15g sine 60 plus 3g root 3 cos 60. I've still got 9.8 stored as a, so it's going to be 15a sine 60 plus 3a root 3 cos 60. Close the bracket, equals, so n is going to be, so I'm going to write that all out, 152.8, and then to two significant figures. Two more significant are the 100 and the 5 and the 50, so that's going to be 150 newtons to two significant figures. So if you're in doubt, then that's what I suggest you do. If you're not sure whether or not to round, write the calculated value, and then underneath it write the rounded value to two significant figures. Okay, so we're getting quite complex equations that we're building now.